During the second week for the course Quality Design and Control, I intend to cover the following topics. There will be 5 lectures, and essentially during the second week I will be talking about some basic issues related to management of quality. And on management of quality there will be 2 parts. So the second week I will be talking about the management of quality part 1, and in the subsequent week on during the third week I will be discussing the second part of management of quality. As you might have noticed by this time that the management of quality, when we discuss, it covers a large number of topics in fact, and I intend to cover all these the topics in a systematic manner. During this week there will be 5 lectures. On lecture 1 I will be discussing the quality engineering, the basic concepts and objectives, stages in quality engineering, what steps you need to follow if you want to apply quality engineering based tools and techniques. And lecture 2 I will be talking about basically this is on the quality management aspects, basic concepts and objective, and the stages in quality management. And lecture 3, quality principles in product development, concept of extended process, customer driven improvement cycle, principles of supplier selection. These are the specific topics I am going to cover. Lecture 4, quality principles in product development, part 2, process improvement cycle, variability reduction and loss function, principle of zero defects in product design. And in lecture 5 I will be covering 4 absolutes of quality management, quality trilogy process, and quality improvement principles. So this will be the broad coverage under management of quality part 1. Okay. Now let me first discuss the quality engineering, its basic concepts and objective, and what are the stages in quality engineering that you come across. Okay. These days we have been using the term called quality engineering, and there should be very clear ideas about what actually it is and what actually it does. Obviously, the main objective of quality engineering is to design quality into every product and process. So this is the core objective of quality engineering. That means as simply designing a product is not enough. You have to follow a separate the approach for building quality into the product during the design stage mostly. Now the objective of quality engineering is achieved by using an approach called robust design. That means whenever someone says that he is working on quality engineering, you may assume that he or she is trying to design a product and which is essentially robust in nature. So with the help of quality engineering based tools and techniques and approaches, the product is designed such a way that it becomes robust. Later on we'll define what is this robustness and all, the robust. The philosophy and the robust experimental design principles were originally developed by Taguchi. In fact, this particular term quality engineering was coined by him, Taguchi, and while he proposes an approach for creating a robust product, he emphasizes on using experimental design and experimental design during prototype stages. That means he is essentially focusing on the offline quality control technique. Taguchi's methods are useful in identifying the key factors that have the greatest contribution to variation and to ascertain those settings or values that result in least variability. So, that is very important in fact, as I have been telling all the time, and in any exercise on quality is essentially an exercise on variability, and you design a product in such a way that the performance variability should be under control, and this performance variability should be as minimum as possible. So, Taguchi methods actually focusing on this particular aspect, and hence robust design is considered to be a systematic approach what actually he proposes to find the optimal values of the design factors leading to economical designs with low variability. That means the quality is to be maximized, but at what cost? So, make sure that the cost is also at the minimum level, and so also the variability in the product performance. Now, Genichi Taguchi, the well-known Japanese quality guru, has focused on an aspect of product quality that has remained as an important one for product development, and this is a part of product development, but has been ignored or not emphasized by others in the past. And when he introduced the concept in 50s, initially there was a lot of problem, but he stood firm, and he says that your objective should be to create a robust product. Now, what is a robust product? That means the product performance may be affected by several kinds of external noise factors. Now, obviously, you have to search for ways and means with which the effect of such noise factors on the performance of the product should be made as minimum as possible, and in that condition the product is referred to as a robust product. Now, he says that quality is a loss a product causes to society after being shipped, other than any losses caused by its intrinsic functions. That means, as I have already mentioned during the first week, that there are different definitions of quality, and the definition given by Taguchi is a unique one, in the sense that he relates quality with the loss, and he calls it as a societal loss. So, if against a particular product which you have designed, if you can measure its loss, and that you have to do, and you say that I have designed a product, the loss is minimum, and that is why the quality is acceptable or the quality is very high. So, this is the basic issue. Now, he says that quality can be manufactured or engineered into a product, and that is why he refers this concept as a quality engineering. So, keeping in focus the performance of the product as the primary objective of creating acceptable design. So, the design means what? Means you create a design so that the performance of the product is guaranteed. Now, when he refers to the loss, there are two types of losses normally we come across. Loss caused by the variability of function, that is obvious in fact, and the second type of loss caused by harmful side effects, right? Now, so there could be several examples. Later on, we'll highlight those examples in the subsequent lecture classes. So, there are two types of loss. The first loss is caused by the variability of the function, and the second loss is caused by the harmful side effects. Okay, so now there could be the several examples of these two types of losses. For example, breakdown of a machine at the workplace and non-starting of a car on the highway are two specific examples of the loss of the first type. So this is always we come across because of some bad settings. That means as I've already mentioned that when you design a product and you try to produce it, that means we by a process. So with respect to that process, you must be able to identify the process parameters with which these process parameters you set at such values that you get the design of the product manufactured as per the specifications. So because of some bad settings, so process settings essentially, the machine cannot run at the optimal speed and the corresponding loss in production may be treated at a loss of the first type. So this always happens in fact. So any machine is installed, and when you start using that machine for producing a particular component, so obviously with respect to the component design specifications, and so you need to set the process parameters, okay, at the required the values. So this whole exercise is essentially known as the process setting. Now if the process setting is wrong, obviously what you may find that there will be a loss. That means we will be producing a component which may not be able to conform to the specifications. And if you start using that particular component or the part or the product, obviously the entire system just cannot run at the best possible the manner. So that's why there will be always the loss. Okay. So variability in the quality of services provided by the hospital staff may result in unsatisfied patients, increased waiting time, and increased treatment costs. So this is another example of the societal loss or loss in general in respect of a service function or service activity. Asbestos is an excellent insulating material. Nobody can deny this. However, the persons using it may be prone to cancer, and hence this serious effect is considered to be a loss due to harmful side effects. This loss is present in most medicines used by patients for cure of a specific disease among humans. Can you, this is a serious concern. That means for a particular treatment, definitely medicine you can use, but always there may be harmful side effects. So this harmful side effect is referred to as loss. And if you can reduce this harmful side effect, we say that the quality of the product has increased. And unacceptable product which is scrapped or reworked prior to shipment is viewed by Taguchi as a cost to the company, as it reflects production inefficiency, but not a loss to the society. Now, maybe that means it assumes that whatever inefficiency you have in the manufacturing systems, okay, you should control them, and later on you might say that I don't have any the production inefficiency. That is the goal. And obviously, these are there could be many internal factors contributing to this production inefficiency, and you should be aware of. You should be able to identify those factors, and in course of time, you must be able to remove those factors from the system. Losses caused when a product performs as intended are not considered quality losses by Taguchi. So this is an important point to be noted. For example, the effect on the health of a person consuming alcoholic beverages designed and developed by a company may not be treated as a loss at all. Okay, so this is a controversial the topic in respect of a particular product. His reasoning here is that the such situations reflect cultural or legal problems, not engineering problems. means the legal issues or the cultural issues must not be brought in, or ethical issues must not be brought in. So our focus is on engineering problems, and related to the engineering design, related to the engineering systems, we will be identifying the loss. So this is the boundary line we must create. Otherwise, this product may be treated as a loss to the society. Is it okay? So long it is the state is allowing it to is produce. So obviously, while we quantify the loss, we must treat it as an engineering problem. Another example of this case is an automobile accident caused by someone who has a radar detector and is driving too fast. The extent to which the proper functioning of the radar detector caused a loss to the society is not treated as a quality loss. So you should be very careful that under what context this quality loss has been defined. This is very, very important, and you must set a boundary line while you deal with such problems. Okay. Now I've already mentioned that ultimately if you intend to use quality engineering based tools and techniques with respect to a product, the main objective is to create a robust product. And so the robust product you can create only when you are aware of the characteristics of a robust design. So that means the robustness deals with the products and the process both. It's not only you say that the product is robust, you also must say that by the machine which I am using it, the process I am using, that is also robust. Robustness can be further defined as the ability of the product to perform consistently as designed with minimum effect from the changes in uncontrollable operating influences. That means always there will be the existence of uncontrollable noise factors like humidity, like say the temperature, like say the dust, fumes, working environment. Okay, so the skills of a particular with the persons, the variation in the skills. Is it okay? So you cannot avoid that, and so how to minimize the effect of uncontrollable noise factors on the performance of a product. So that is the key issue while you create a robust the design for a product. From a process point of view, robustness can be defined as the ability of the process to produce consistently good product with minimum effect from changes in uncontrollable manufacturing influences. Is it okay? So this way the robustness has been defined with respect to a product, with respect to a process. Okay. Now the Taguchi's approach is to identify and control those factors that are significantly cause variation, and to do so in a way that minimizes the effect of those variables that cannot be controlled or that are not practical to control. So this is the point to be noted. Okay. So although engineers at Bell Labs and Xerox were the first in the United States to experiment with the Taguchi methods, so they are the pioneers in fact, Ford was the leader in changing company policy. That means the companies like Ford, many such companies in the subsequent years, subsequent period, they have adopted the Taguchi's the robust design approach in designing as well as in manufacturing their products. So it's a well-known technique. So this is sometimes referred to as the quality technology. So this the quality engineering based or the quality technology based the techniques as proposed by Taguchi was first introduced to the US automotive industry in March 1982. In the beginning, this effort was fostered by a very aggressive forward drive to improve quality and reduce cost. As I have already mentioned, that you have to improve quality all the time of a product, and you have to reduce the cost at the same point, or concurrently you have to do that. This has evolved fundamental changes in US engineering and quality control methods that have changed many US companies' operations. So this is the background. Now, whenever sometimes the Taguchi's method is referred to as the Taguchi philosophy. That means when you adopt this particular the methods, your the mindset must change, and you really the change your attitudes for quality improvement in production processes. So there is some fundamental changes in the attitude. So that's why sometimes these Taguchi methods are referred to as a Taguchi philosophy. So in order to improve an overall quality and productivity, so you will definitely improve, you will always try to improve the quality, but you also make sure that the performance and the productivity of the systems, or the performance of the productivity of the products concerned must also improve. So the company to achieve this, that means both quality improvement as well as productivity or performance improvement, company there you have to engage yourself in several types of activities. So these are obviously this is the responsibility of the company, and the main activities are or the company's activities in this context is product planning, product design, process design, then production, for production, and the last one is a service after delivery. So these are very important, and when you look at all these activities, you will find that essentially we are trying to give importance to all the dimensions of quality. Now, two types of undesirable and uncontrollable factors we have not yet discussed in detail, or we have not yet classified the various kinds of uncontrollable noise factors. So there are essentially two types of undesirable and uncontrollable factors that may cause deviation from the target values in a product's functional characteristics. A product may have different quality characteristics. Now, in each quality characteristic, you have to identify the best possible, the nominal value or the desired value. Is it okay? And you target to achieve this desired value. So it's not the mean value. It's basically the target value you want to achieve. And when you start using the Taguchi method for quality engineering, so the target values must be known. They are known as, now these two types of factors, uncontrollable noise factors, are classified as external noise factors and internal noise factors. Now, external noise factors are those variables that are external to the product and affects its performance. So that is the external noise factors. And so what are the examples of external noise factors? Like changes in operating environmental variables such as temperature, humidity and dust. That means they are existing external to your systems, to your boundary line, but definitely they may affect the performance of the product. Okay, so these are external noise factors. You have also internal noise factors. Now, so the variability in human operators who are responsible for making the product is internal noise factors, which is unavoidable. Is it okay? If suppose you engage the 3 persons for producing or manufacturing a component or the product, so obviously there will be the differences in their skill levels, and this variability is unavoidable. So this is considered as one example of internal noise factors. Now they are due to the settings of the product and the process parameters. So sometimes what happens, if you engage person A, he will set the machines in one manner. If you engage say another person, say person B, on the same machine, now he might set the machines in a different manner. So obviously you set the parameters of the machines in such a way that you can handle it, you can handle the machines properly as per your skills. So the individual to individual there will be variation, and this is referred to as one example of internal noise factors. Now under internal noise factors there are two specific examples. One is the manufacturing variations, which are unavoidable, and the second one is the product deterioration. Okay, so like say due to wear and tear, and there could be many factors which are dynamic in nature. So Taguchi, while he proposes a robust design approach, okay, to create a robust product, he recommends a three-stage design methodology to determine the target values and tolerances for the respective parameters in the product and the process, namely system design, parameter design and tolerance design. So these are the three steps. Now in order to achieve robustness, quality control efforts should start in the product design phase and be continued through production engineering and production operation phase. Is it okay? So this is very, very important. And so what is the system design? Now in this stage, scientific, economic and engineering principles and experience are used to create a prototype of the product that will meet the functional requirements and also to create the process that will build it. So essentially during the prototyping stage, or when you create the prototype, so you follow these rules. For instance, in the research and development phase, R&D, system design involves the development of the prototype design and establishing the parts, components, materials and assembly systems. Okay, so and the determination of the manufacturing process is involved in the production engineering phase. So this is the one. Next you go to the parameter design. Now here what you try to do, that means you try to have the optimal settings of the product and the process parameters. This is you first do in such a way that you minimize the performance, you will be able to minimize the performance variability. Okay, this is the first part you do, and in this context Taguchi defines a performance measure known as the signal to noise ratio. So we'll be discussing this part later on in detail. So this is the signal, that means that is the positive part of the performance, the desirable part of the performance, whereas you also have an undesirable the part in the performance that is referred to as the noise. So if the desirable aspect you improve, and on the noise aspects you can minimize the noise, obviously the performance is going to improve. So he uses a particular performance measure known as signal to noise ratio. Now so there are different measures, there are different ways you can measure the signal. One way to measure it, that's just get the square of the mean value of the quality characteristics, and similarly the noise factors should be selected to represent those that most impact the product's performance. The parameter design process is the most important step in the Taguchi method. And then you go for the tolerance design. So here the tolerances are set, that means a range of acceptable values you must be able to determine around the target values of the control parameters. And narrow tolerances are specified for the deviation of design parameters. So this is your objective, narrow. So if the narrow tolerances you are able to specify, then you assume, or you have created the design in such a way that close control of the process parameters is possible. Now, so these are the three stages, and this parameter design, tolerance design, the quality loss function, online quality control, design of experiments using orthogonal arrays, and the methodology applied to evaluate measuring systems performance. These are all included in the Taguchi methods, and these methods simultaneously reduce cost and improve quality. So the quality losses you have to measure, and as far as possible these quality losses must be measured in monetary terms, and product quality must be engineered or designed in. Quality cannot be achieved economically through inspection and product screening. So okay, so now I will conclude with this particular the concepts, that is what could be the relationship between the quality and cost. So the main purpose of quality engineering is to improve quality without increasing cost. So this has been the challenge. So before the Taguchi introduced the concept, his concept for designing a product, for manufacturing a product, we used to assume that if you want to increase the quality of the product, obviously the cost also will increase. So we used to assume before Taguchi methods introduced that quality and cost are related, like if the quality increases, cost also increase. With Taguchi methods applied, the relationship changes to, even if the quality increases at a particular rate, but the cost may not increase, or if suppose the quality increases at a faster rate, the cost increases at a slower rate. So obviously there are several examples on this we may cite. So later on we will discuss these issues in details. It's just introducing the concept of quality engineering, and ultimately offline quality control, online quality control, many tools and techniques you will learn, and okay, but keep in mind that ultimately whatever you learn, those tools and techniques, methods, methodologies, you must be able to use to create a product, to create a system, to create a process robust in nature. Thank you.